So what I've presented here is a dot plot. We've already talked about dot plot in this unit. Here my dot plot is the time to get to school for a number of students. You'll notice immediately looking at the data that most students fall within this range, from 9 minutes to 19 minutes, with the majority of them being even more condensed in the center, 13, 14, or 15 minutes. You should also notice there's a few outliers here. One student lives particularly close, they live 6 minutes away, and then 2 students live 22 and 23 minutes away. What we're going to talk about today is how to move from a dot plot, which is one way to express one variable data, to a histogram, which is a separate way to express one variable data. Now these are very similar ideas. The histogram just provides a more compact version of what a dot plot might represent. So for example, if I had a dot plot with 1,000 data plots, or 1,000 data points, it would be unreasonable for me to expect to fit them all on my dot plot, and that's when I might use a histogram. So let's show you how to move to a histogram. The first thing is we need to decide how we want to break them up into intervals or bins. The intervals or bins are what portion we're looking at. So for example, for my dot plot, I might want to take a bin of this many minutes, or this many minutes, or this many minutes. The school has decided that they want bins of 5 minutes. So for my interval, I'm going to go from 0 minutes up to 5 minutes, from 5 to 10, from 10 to 15, from 15 to 20, and from 25 to 30 minutes. So those are my intervals. The next thing we need to do is count my dots. And we're going to keep a tally of those using my table. So if I look from the interval from 0 to 5, we look at my dot plot. There are no students who take 0 to 5 minutes, so there are no tallies. Therefore, the number of students must also be 0. If we move on to the next interval is from 5 to 10. So 5, it doesn't show up, so there's no one there. We have 1 for 6, so make a tally. None for 7, none for 8, 1 for 9. Now, the 10 presents an interesting problem. Do we put it in this interval or this interval? Well, when we talk about histograms, they're always defined as greater than or equal to the lower number, which is 5 here, and less than the bigger number, which is 10. So my data point has to be greater than or equal to 5 and less than 10. Here's the 10, that's actually going to fall into this interval. So we have only 2, the 6 and the 9 here. We count those up, we have two students. The next interval, from 10, we have 1 for 10, we have 2 for 11, we have 2 more for 12, that's a total of 5. Keeps on to 13, we have 4 for 13, 1, 2, 3, 4, and we have 5 for 14. So we have 1, 2, 3. So if we add up the total from 10 to 14, remember that 15 is going to go into the next interval, we have a total of 14 students. Notice how we're condensing the data from every single point to just one number. Here it's 14. From 15 all the way to 19, remember we're not going to include the 20, we have 1, 2, 3, 4, 5, 6, 7, 8. We had 1, 2, 3, 4, 5, 6, 7, 8, for a total of 8 students. If you don't want to use the tally here, that's perfectly fine. From 20 to 25, we have only these 2 students. And then from 25 to 30, there's no one listed, so we're going to throw in a 0. Now that we have our table, we're ready to move on to the histogram. The histogram over here has an x and a y axis. We want all of our axes to be labeled as always. On the x-axis we have the number of minutes from school, just like we used in the dot plot. And the y-axis, instead of the dots, we're going to actually draw rectangles. The y-axis here is going to represent the number of students. So using this table, we can complete this graph. On the x-axis, we want to write our intervals. So we went from 0 to 5, 10, 15, 20, and 25. Those were the intervals we have from our table. The next thing we need to do is analyze our number of students. We go from 0 all the way up to 14. So let's break this down in terms of 5. So this will be 5, 10, 15, and we'll just do a rough approximation. Now, to draw the histogram, you look at your interval and you look at your number of students. So for my first interval, it went from 0 to 5. We had 0 students. So instead of drawing the rectangle, there actually are none. So for that case, your line is just going to remain on the bottom, or you can completely ignore it. The next interval, from 5 to 10, we had 2 students. 2 is about here. We draw our line from 5 to 10, and you want to connect it as a rectangle down to the x-axis. Moving along using the same procedure, from 10 to 15, there's 14 students. That's all the way up here. So you draw a much bigger rectangle in this case because there are much more students. It's a higher frequency. From 15 to 20, I have 8 students. 8 would be approximately right here. We draw a rectangle connected to 20. And from 20 to 25, we have 2 again, which would be the same level as before. And then from 25 to 30, we have 0. So you can simply draw a line exactly on the x-axis, or you can ignore it. Notice that the histogram presents the data in a similar manner to the dot plot. There are very few students out on the fringes. There are a lot of students concentrated right in the middle. However, instead of representing every student, the histogram has combined all those students to represent them all in one rectangle here. We notice that here there are 14 students. So the histogram is a good way to organize your information as long as you have a lot of data points and you have the discrete data points. You know where each data point is going to be. Good luck.